Hi. So this is a quick run through of our code for the blockchain based e-voting system. So right now, I'll start the first of our two main components, which is the election server file. This is a central server all that represent different voters. So I'm starting this file, and the other file is the election client, which I'm starting now. This each client represents different users or voters of the system. So for now, I have created three clients. Just to give you a quick run through, the type of clients is of two basic types. The first type is a general voter or a normal user, and the second is an election official, which will be using the same election, which we will be simulating with the same election client.java file. So as you can see, the client as well as the server is running. So here we see that the server is running on localhost on port 8000. So we begin by initializing the candidates list of the server. For example, here I am giving four candidates. So these are initialized in the server, and these would be the four candidates in the election. So now going to the first client, the first thing that a client has to do is to connect to the server. So this communication between the client and the server is achieved using socket programming. So the command we have created like dummy commands, which are similar to FTP commands. So election client, and the second parameter is the host name of the server and the port on which it is running. So as you can see, client one is successfully connected to the server, and it is also logged on the server that client one is connected. Now the second thing that every client has to do is to input its username. Now if the username exists in the server, it will simply just verify if it will be a login action. But if the username doesn't exist, it will register that username onto the server. Now for example, let's consider the username as user and the password as password. So here you can see that the user is authenticated, and it is connected to the server. Now this user can proceed with the different commands such as vote and other commands. Now for the second client, we will again connect similarly to the server. Let's make this client as the election official. Now the election official in our system has a special property that it has the username as election head, and it is based on this special username that it is granted a special access to end the election, which I will be demonstrating further. And let's put a dummy password for him. So this person or this user is connected. And similarly, we will create another user. First it's connecting, and now we have user one, a password. So now let's begin voting. So the first step is to write the command as vote and space separated with a candidate ID. Candidate IDs are zero based. So let's say this person wants to vote for the first candidate ID, so it will write vote 0. Now because this person has not voted before, the system actually went through it, checked if this person had voted before or not, and as he has not voted before, it got the message that that person voted successfully. And on the server, you can see that there is a vote request from client 1 and which ID it is voting for. For this person again, let's see if we can vote again for some other person. Then in this case, we don't allow voting, and we get the message that you have already voted. Let's see for another vote by another user. So here, let's see if this person is voting for vote 0 again. So now we see on the server there is another request for candidate ID 0, which is C1. Now let's end the election. This election command can only be run by the election head. Now let's try ending the election by someone else. So here you get a message that you are not authorized to end the election. Whereas if you do it from the election hand process, then you get the result that the winner is C1 because that person had the most number of votes. And this is also displayed on the server. And now we see in the backend how we are building it on the blockchain. We have used a JSON file where we are appending different blocks, and that file is located over here. And as you can see, each block is represented with the following way. The first thing is the vote counts of a list, which is a list of the votes received by each candidate. Then it has a nonce value, a timestamp of when the block was written. And as you can see, there are only votes. These are previous votes received in the blockchain, which we had run in previous runs. And you can see at the end, these are the current 2 votes that I just submitted in this demonstration. So initially there was a vote for candidate ID 0, which is C1, and then there was another vote for that same candidate ID, so the vote count increased to 2. So yeah, this is just a quick demonstration of how we have achieved a simulation of blockchain based e-voting through Java programming. Thank you.